So hello and welcome back. Today we will have another example of the law of conservation of energy, which states that power delivered equals power absorbed, or that energy can neither be created nor destroyed, only transferred. And we are going to analyze a circuit with a 5 amp current source, a 3 volt voltage source, and 2 resistors, a 3 ohm and 4 ohm resistor. Remember that Ohm's law states that V equals I times R, and since all of these elements are in series, they share the same current. So to find V1, that is 5 times 3, or 15 volts, and to find V2, that is 5 times 4, which is 20 volts. So Kirchhoff's voltage law states that the sum of the voltages around the loop is equal to 0, so the voltage across the 5 amp current source is going to be the voltage across the 3 ohm, which is 15, the voltage across the 3 volt minus 3 plus the voltage across the 4 ohm, which is 20, so that's 32 volts. So now we can find the power by using P equals V times I. The power delivered by the 5 amp current source is going to be 32 times 5, which is 160 watts. So the power delivered for the 3 volt source is going to be 3 times 5, which is 15 watts. The power absorbed for the 3 ohm resistor is going to be I squared R, so that's going to be 5 squared times 3, which is equal to 75 watts. And the power absorbed for the 4 ohm resistor is also I squared R, so that's going to be 5 squared times 4, which is 100 watts. So when we add up the absorbed, it equals 175 watts, and when we add up the delivered, it equals 175 watts.